computer. All right. Happy Tuesday. We're in week 3. You're all still with me. We've survived. We've made it this far. I'm so excited to be here. I really love tonight's lesson. I think I said that before. I think I might have said that on Thursday, but I do. I really, really love this lesson. This is a good one. And we will need our fancy calculator. We're not learning something. Um, we're going to be using the same function that we used on Thursday, but I'm going to give you more stuff for it. So tonight, our objectives, tonight, what we're working on is we're doing section 3.4 and 3.5, and we're going to go over lab 2. I will walk you through that. I'll do lab 3 on Thursday. Tonight, you're just going to need the continuous data from lab 1. So that's all you need. I would do want to let you know all the labs are graded and I left feedback on them. So you should be able to see the feedback by clicking on it, clicking on the assignment again and going back into the lab. The feedback should be in there. So I tried to give pretty good feedback there. Um, the assignments that are due tonight, which ones are due tonight? To the beginning 3.1 and 3.2. I believe those are due tonight. So those ones have a couple of questions that on each one of them that are manually graded. So it's not going to give you a grade for those ones. It'll show a 0 until I manually grade them. So don't freak out. I will be going in and grading them. And if I take any points off, I will leave feedback. So if there's no feedback there, I haven't graded it yet. And I usually wait until after the due date, as I've stated this before, because sometimes you answer all your questions and everything, and this happened to me a lot when I was in school. It still happens actually. You do them all and everything, and you're like, okay, this is good, it's submitted. Then you go to bed or go to work or go to do something else, and you're like, wait, that was a terrible answer to that question. That totally was not what I meant to say. And then you want to go back in and you want to change it. If I've already graded it, then you're not going to feel like you can change it, or I won't notice that you changed it. So I save that grading until after it's due. So I will start grading it tomorrow. Then the hand-in homework that's due tomorrow, that's you're going to do that on paper and then you're going to upload that. Once again, I won't start grading it until after the due date because once again, maybe you realized you uploaded it funny or you didn't like your answers and you want to re-upload a new one. I want to make sure that you have the full time up until 11:59 p.m. to get that submitted just in case, because you just never know. We just never know. And I don't want to grade it if you're not ready for it to be graded. So you will, my password went back up there. Okay, so don't freak out if it shows as a 0. The hand-in homework will show as a 0. It's not affecting your grade. I don't have it categorized. It's not affecting your grade, but it's going to show as a 0 until I grade it. So just letting you know, don't freak out. I mean, who am I to tell you not to freak out, but don't freak out. If you just, sometimes we just want to freak out a little bit. If you really want to, go for it, but don't. All right. So this is what we're doing tonight, and it's fun, and I think it's fun. It's useful. You you may think you've never heard of z-scores before, but let me tell you, once I teach you about z-scores, you're going to hear people talking about them, or you're going to hear people talking about how many standard deviations away from the mean things are. In fact, I just heard it on the news this morning, somebody talking about how many standard deviations something was from the mean. And I was like, that is so cool. I'm teaching that tonight, and it was really exciting for me. Much more for me than it is for you, but hopefully, if you hear it on the news after today, you'll be like, yes, I just learned that. I know what that means. All right. So, one of the big topics that we're learning tonight is about z-scores. So, z-scores are completely tied to standard deviation. So, you remember me talking with the empirical rule, talking about values that are 2 standard deviations away from the mean. So, if I go 2 standard deviations above the mean, and 2 standard deviations below the mean. That's part of that 95th percentile. So let me just draw my picture. So if I'm here, here's my mean. This is my perfect, beautiful drawing. If I take this mean and I add two standard deviations to it, I land there. Or if I subtract two standard deviations from it, I land there. And this is 95% of my data. We know that this is where the usual data lies. Anything that's not inside this 95 percentile right here ends up being, or 95% section ends up being an outlier. So it's kind of nice to know how many standard deviations something is from the mean to know whether it's in this usual region or if it is an unusual value outside. I'm going to erase all this ugliness even though it was not a bad curve, if I do say so myself. So, in order to reference or how many standard deviations something is away from the mean, we use something called a z-score. Now, we calculate both population and sample exactly the same. We just use the different symbols depending on what we're calculating. So to calculate a z-score, you take the data value. I'm going to use a different color so it stands out better. You take the data value, you subtract the mean from it, and then you divide it by the standard deviation. This will tell you how many standard deviations something is from the mean. It'll help you to determine whether or not is an outlier, whether or not it is unusual. So if I calculate something and I get a z-score of 2.13, then I know that that is more than two standard deviations from the mean, so it is unusual and it's considered an outlier. So with z-scores, we have positive z-scores and we have negative z-scores. A negative z-score means that we are below the mean. So if I had a negative z-score of negative 1.3, then I know that my data value that I'm looking at is 1.3 standard deviations below the mean. So if I took, well, I'm going to do some examples and it'll make more sense and hopefully you'll ask questions if it's not. But so basically the z-score is just a distance. It is a distance telling me using standard deviations as my unit of distance of measurement, how many standard deviations am I away from the mean? Now, we don't use units on z-scores, so we don't say feet or miles or inches or ounces or, I don't know, pineapples or whatever. It is unitless. So it's not going to have the units. When we do after we do the examples, hopefully it'll clear this up and make it understandable. And if not, you can ask questions. So let's give an example. Okay. So the mean height of males 20 years or older is 69.1 inches. So this is my mean with a standard deviation of 2.8 inches. This is my standard deviation. Okay. The mean height of females 20 years or older is 63.7 inches. This is my mean with a standard deviation of 2.7 inches. So this is obtained from the National Health and Examination Survey. We want to know who is relatively taller, Kevin Garnett or Candace Parker. Okay, by looking at their heights, Kevin Garnett is 83 inches tall and Candace Parker is 76 inches tall. They are both tall. There is no argument there. They are both tall. As somebody who is 62 inches tall, those are really tall people. But Kevin Garnett is compared to all of the other males, and we can look at it and say, oh yeah, he's tall. Candace Parker is being compared to all of the females, and we can say, yeah, she's tall. In order to compare them to each other, we need to standardize it. So if we find their z-scores, we can see which z-score is more extreme, so we can see who is relatively taller. Kevin Garnett is definitely taller, but if I'm comparing him to the males and comparing her to the females, for a female, is she taller than Kevin Garnett is for a male? So let's calculate the z-score. I'm going to put the formula up here on the top. Z equals x minus mu divided by standard deviation. Okay, I'm going to do him first. I'm going to do him in red because I have his stuff underlined in red. So I take his height, which is 83, subtract the mean, which is 69.1, and divide it by the standard deviation, which is 2.8. This is going to give me my z-score. If you put this all in the calculator at once, you need to put parentheses around your numerator. Don't forget to do that. Make sure you have those parentheses around your numerator. So I'm just going to put this in my fancy schmancy little calculator. Uh-oh. And attempt to not typo. So Kevin Garnett's z-score, his z-score is 4.96 or about, it's rounded. And that's crazy. Because remember I said that anything more than two standard deviations away from the mean is an outlier? This man is almost five standard deviations above the mean. So I'm going to do my little quick thing here. Well, that's really ugly. Okay, let's try it one more time with feeling. So you remember 99.7% of all of our data is within three standard deviations of the mean either way. He's way out here. This is really ugly. He is way out here. He's in the tail. He is way off the chart. That's okay. He's just really tall. This is basketball. This is what we are. Okay. So now we're going to use the green and we're going to calculate the z-score for Candace Parker. So I'm going to do it over here on the left. So z equals, her height is 63.7 inches minus the mean. Oops, I did that 76, sorry. Minus the mean, 63.7. I was getting ahead of myself. It happens. And divided by the standard deviation. Don't forget to put this in parentheses if you if you're going to put it all in your calculator at once. Divided by 2.7, enter. Okay, so her z-score 4.56. Holy cow, she is also very tall. She is extremely tall. However, relatively, she's not quite as tall as Kevin Garnett. His z-score is 4.96. Her z-score is 4.56. So she is still not quite as tall relatively as he is because his z-score shows that he is more standard deviations away from the mean. We have another example, but before we do that, what questions do you have, if any? All right. All right. Go to the next example. You are going to calculate this. I will calculate it slowly behind you, but I want you to try ahead of me. And you can type your answers in the chat if you're comfortable. So the Angels score 773 runs and play in the American League. In the American League, the mean is 677.4. The standard deviation is 51.7. Now, the Rockies, they scored 755 runs. They're in the National League. The mean in the National League is 640 with a standard deviation of 55.9. I'm going to write the formula here just in case. I would like you to calculate both of those standard deviations or both of those z-scores to determine which one is relatively, which one did relatively better, which one had a relatively better season. Obviously, the Angels scored more runs, but compared to the rest of their leagues, we're trying to determine which one did relatively better. So go ahead and do the Angels first. If you're comfortable, you can type your z-score in the chat for the Angels. Angels need to be green. I'm going to let you get a head start here. Y'all are fast. Okay, let's see here. I see that we're getting some same answers in here. That's awesome. So 773. Whoops. Work quietly. My decimal point is terrible. Oh, no, it doesn't need a decimal point. Ugh, there we go. What do you know? I got the exact same as y'all. Okay, go ahead and work on the Rockies. I also got 1.85. Good job. Once you get the Rockies, feel free to type it into the chat. Looks like a little variation. Let's see what we get. They're all really close, but wonder if it's rounding errors. I don't know. Seems to be the most common. Or calculator typos. Oh, there you go. Okay, let me see. I agree with the 2.06. I agree with that one. Okay. So it looks like by looking in the chat, it looks like most of you got the 2.06. If you got 2.05, it's probably because of rounding, because the number after the 5 is a 7. But what's important here is you got the process correct. This looks really good. Oh, yes, yeah, I see you corrected yourself. Good job. All right. So looking at these numbers, who had the relatively better season? Whose season was relatively better? All right. The answers are coming in and they look good. You are right. Because the Rockies had a higher standard or higher Z score, their Z score is 2.06, whereas the Angels is 1.85. The Rockies had a relatively better season. And because the Rockies' Z score is greater than 2, even just barely, they're an outlier. They had an unusually good season. Yes, they scored fewer runs than the Angels, but because of this mean and the standard deviation, compared to the rest of their league, they had a relatively better season. Does that make sense? Okay, questions before we move on? Okay, good. Thank you. Questions, comments, queries, concerns? Z-scores are super helpful. So one thing that I do um, after the first test, which coming up next week, and I'm going to talk about that at the end also. Um, so one thing about the test is now that you have this Z-score information, now that you know this stuff, I, after the test, I will give you the mean and the standard deviation of the test, and you can calculate your own Z-score to see where you scored compared to the rest of the class. This is something that's super easy to do. It does not, you can't see all of the individual scores, so you have no idea what other people scored, but you can see how you did relative to the class. And it's actually just super cool to just know that mean and standard deviation and be able to look at that. There are many studies that I've read that they will give me a mean and a standard deviation. They'll give Z scores, and it really helps you to understand what's going on. All right, let's move on. Okay, so now I want you to take mean and standard deviation information. I want you to put that in your pocket. We're going to leave it alone for a little while, and we're going to really focus on median today. So put the mean and the standard deviation in your pocket, and then we can move on. All right. So long, long time ago in the land of, I think it might have been last week, it might have been week 1, where we did mean, median, and mode. Actually, that was last week. It was Tuesday. We did mean, median, and mode. We calculated how to find the median. We determined that the median was that center number. So we're going to take it a little bit further because we need to be able to find outliers with median. We've learned that with standard deviation and mean, that any data value more than two standard deviations from the mean is an outlier. That is really great if we're using mean and standard deviation. But we determined previously that when we have data that is skewed, we want to use median instead. So we need to be able to find a way to have outliers with median, and that's what we're going to do here. Okay, so this diagram is more helpful than the words. The words are important, but the diagram is going to probably be your biggest help here. And I'm just letting you know that this is something that you if you need visuals for your notes for when you get to the test or your homework or whatever, this is something you might want to tab. So quartiles basically just divide your data into four pieces. So remember the median, cut it in half and split it so that 50% of your data was below the median and 50 was above. When we're dealing with quartiles, we're now going to be splitting it into four equal pieces. So the from the smallest data value to the quartile 1 is 25% of your data. Between quartile 1 and quartile 2, which is also known as the median, we almost never call it quartile 2. It technically is, but we just refer to it as the median. So between quartile 1 and quartile 2, that's 25% of your data. Between the median, which is quartile 2, and quartile 3, we've got another 25%. Then between quartile 3 and the largest data value, that's the last 25%. So we divide it into quartiles. So we have four equally sized sections. I'm going to show you how to find those in just a second. Okay. So as we did before, you want to arrange your data from smallest to largest, and then you find your median. We've already become quite good at finding median, which is good because now what you're going to do is you're going to take the half of your data. So I'm going to go back to this picture. Take this half of the data that's below the median. Take that and you're going to divide that in half. So you're going to find this right here is the median. I need to put it in a pen. This would be the median of the bottom half. So in order to find quartile 1, you take the data values below the median and you find the median of that. And that is quartile 1. Then I'm going to highlight up here. This up here, you're going to take the upper half as if it's its own data, as if it is its own data set, and you're going to find the median of the upper half. And that's going to give you quartile 3. So we've split it into four equal parts. It's going to make so much more sense once we're actually doing it with data, but that is how we find those. So we're going to take this data right here. I already put it into order from smallest to largest because we know how I struggle with that. That is my weakness, putting it into from smallest to largest. I don't know why. It just is my problem. So we are going to find the quartiles for this. So what this is data that a group of Brigham Young students in Idaho, they were at a construction zone and the speed was posted 25 miles per hour. So what they did was randomly selected 14 vehicles and they recorded the speed that they went through the construction zone. As you can see here, most of them are going faster than 25. That's not cool, but it is what it is. So this is 14. I'm sure, hopefully, somewhere in your noggin, you remember how to find the median of an even number. So I have 14 here. Therefore, my median is going to be between car 7 and car 8. 1, 2, 3, 4, 5, 6, 7, right here. This is so my median, we would take those two values, you add them together and divide by 2. Hopefully this is not brand new information for you. So my median is going to be 32.5. This is the median. You also can call it quartile 2 if you like, but we generally don't do that. So now I've split this into two separate like pieces. So I have the bottom half and I have the top half. To find quartile 1, we're looking for the median of the bottom half of that green section. That's what we're looking for. Because we split it into two parts, there's 7 in the bottom and 7 in the top. So my median would just be this one right here. This is that center value. So this right here is quartile 1. Whoops. That's quartile 1. Let's do the same thing for the top. Let's get better purple. There we go. So at the top half, we also have 7 there. So 1, 2, 3, 4. This is quartile 3. Q3, right there. All it means by interpreting it, all it's looking for is for us to recognize, I need better blue. We recognize that down here, this is 25% of my data. 25% of my data is here. 25% of my data is here. And 25% of my data is here. That's all it's looking for interpretation. It just wants you to recognize that each of those little sections contains 25% of your data. And 50% of the data is below the median and 50 is above. And then we split it into those two 25% pieces. What questions do you have, if any? I'm going to have you try this in a minute. Probably less than a minute. Okay. Okay, a little longer. See, this is the interpretation. 25% of the speeds are less than or equal to the first quartile. Notice it says less than or equal to. So it basically includes the 28 because the 28 needs to live somewhere. So it's less than or equal to. So it's kind of including that one. Then 50% of my speeds are less than or equal to the second quartile of 32.5. 75% are less than or equal to the third quartile of 38. So the 38 is being included in that bottom. It's not, I don't know, I had words, they left. Okay, it'll probably land again. Okay, and 25% are greater than. Notice it just says greater than and not greater than or equal to. It's greater than 38 miles per hour. All right, questions before you do it on your own? All right.
Will we be asked to interpret a quartile on a test?
No,
Like,
you're not going to be asked to interpret. I'll just ask you what they are. I won't ask you the less than or equal to or any of that. I just kind of want you to have an idea, because when we do it on Excel, it asks you whether you want to include the Q1 or exclude the Q1. And so I'm showing you here, since it's less than or equal to, we're including that Q1, if that makes sense.
thank you.
You're welcome. Yeah, but it's not going to show up on the test. And I actually don't think you get terribly different answers if you exclude or include. I don't, but this is just, it is what it is. But good question. All right. So this is highway loss data. So basically, there's people have gotten into car accidents and then they submit claims to their insurance companies. So these are the collision, the coverage that has been submitted. These are the claims, the amount of the claims. And I put them in order from smallest to largest. There are 18 here. So I would like you to find Q1, the median, and Q3 of this 18 data value set. So go ahead and find those. So Q1, median, well, you're going to find median first, but median, Q1, and Q3. So I'm going to give you a moment to do that. Working quietly behind you. Okay, good job. Yes. Fantastic. Fantastic. I love seeing all these beautiful correct answers coming in. All right. So the median, as shown in the chat, median is 1805. We had to add those two middle numbers together and divide by two. Then because we had odd numbers in the top and the bottom, good job. Yay. Because we had odd numbers, it was pretty easy to find our Q1 and Q3. Yes, good job. Look at all those great correct numbers coming in. Woo! And did you just throw the 21 147 in there because you're like, yeah, that's a big number on the end? I'll take that. I know you almost can put an exclamation point on that because you're like, man, what kind of a car was it that their in claim that they put in was $21,000. Now, was it a I hope wondering if it was a total or if it was a really fancy car. I don't know. I almost wondering why did they even submit the $180 or $189? Bet you they had a deductible there. Nope, there's not a fourth. It's okay. It's all right. I was figuring you were just exclaiming about how much that was. But this is a huge range of data. You can see that we are skewed, and we're going to look at some different ways to see the skew without doing a histogram coming up. Okay, so before I do the IQR, the interquartile range, I'm going to jump back to our other data. So I'm going to jump back. Oh, before I do that, any questions on quartile one, quartile three, and median and how to find those. All right, so I'm going to jump back. I'm going to go back to this speed data right here. And I'm going to put this in the calculator and we're going to take a look at our one variable statistics, the thing that we did on Thursday. And I want to take a look at that screen real quick because it's got some important stuff. So go ahead and grab your fancy schmancy calculator. There's mine. And just in case you forgot how to do it, I'm going to slowly walk us through getting to that's those screens. So we click on Stat and go to Edit, and this is where we enter our data. If you have data in your L1, arrow up until you highlight it and hit Clear, Enter. I am really going to really quickly, every single term I get somebody that hits delete, and I feel like it's not a bad idea for me to show what happens. So if I hit delete instead of clear, I lose my L1 completely. And then I'm like, oh no, what happened? Where'd it go? This is fixable. Notice above, I'm going to see if it will let me zoom in. Notice right here above the delete button, INS, that means insert. So let me show you. I'm going to click second, insert, and it inserts a blank table right here. So I can name that. If I wanted to, I could type words in there, but I'm going to do second one and enter, and it's going to put L1 back in there. Now, if you don't remember that or whatever, if you just email me, send me an email or a message through Blackboard and say, Clyce, I messed up. I deleted my column. I can fix it. I'll walk you through fixing it. But I just wanted to let you know that that's what happens when you hit delete instead of clear. It just deletes your list. And you got to put it back in. All right. I'm going to put the speed or the speeding in the construction zone data in here. It shouldn't take too long. It's only 14. And unless I typo, then it takes a little bit longer. Let me do this. Feel free to do it along with me if you like, with your fancy schmancy calculators. Okay. All right, so I have all of my things there in the column. We're going to go to our one variable statistics. So I'm going to hit Stat, arrow over to Calc. We want the first option. And I want L1. My list is L1. We leave frequency list blank. Go back to calculate. Now, I don't really care what the mean is because remember, mean is in our pocket, standard deviation is in our pocket. Those do exist there, but I'm going to scroll down to the bottom. Okay, gives me the minimum, gives me Q1, gives me median, me Q3, and it gives you the max. This is pretty much all of the information you need from a data set when you're dealing with median. You don't need a whole lot more than that. This is basically it. So it gives you all of this lovely, lovely information. This is worth its weight in gold, though I don't think it really weighs anything because it's like pixels, but you know what I mean. You hear what I'm saying. So if you want to find you're going to need to in your homework find Q1, median, and Q3, it's right here for you. You do not have to reorder thing from smallest to largest and all of that. Because finding them once it's reordered is pretty easy, but sometimes they'll give you a 25 piece data set and you don't want to have to reorder that smallest to largest. So use your calculator. Your calculator is your friend. So use that. Questions about the calculator before we move on? All right, I'm going to bop back over here. Okay, now we're going to talk about IQR. I'm going to bop back over here. So IQR is the short words for interquartile range. Interquartile range, or IQR, is median's answer to standard deviation. Because we don't use standard deviation for median, we use something called IQR. The IQR is the middle 50% of our data. So because this one's pretty, I'm going to use this one. Uh, so it is this right here. This would be my IQR. This middle 50% is the IQR. It's the distance from Q1 to Q3. So you would just take Q3 and subtract Q1, and that gives you the interquartile range. That's all it is. It's a big, huge word for something that feels so small. So for the data for running through the construction zone, take Q3, which is 38, subtract Q1, which is 28. So my interquartile range, the middle 50%, is 10. That's the range of that middle 50%. The interquartile range is what we use to help us to find outliers in our data when we're using median. We're gonna have a magical formula and it's gonna give us what we need. Okay, before I start talking about outliers, I'm gonna show you why we use median and IQR instead of mean and standard deviation when our data is skewed. So let's say that there was a 15th car that decided to travel through the construction zone and it was going 100 miles per hour. It must have been running from something. Who knows what it was running from, but it must have been running from something because it is going fast through that construction zone. Okay, so take a look at the mean and the median. So without the 15th car, they're pretty close together. I would say that this is normally distributed because it's symmetric. These are really close together. But once the 15th car is in there, my mean jumps by 4.6. It jumps quite a bit. It is dragged up by that 100-mile-per-hour car. Take a look at the median. It only goes up by zero point 0.5. So crazy, right? So take a look at standard deviation. Standard deviation without the 15th car. Remember, standard deviation is the spread of our data. How much is it spread out? So take a look. 6.2 miles per hour is the standard deviation without the 15th car. Once the 15th car goes through, it jumps to 18.5. It is crazy how that 15th car changes everything. Take a look at the IQR. The IQR just goes from 10 to 11. It hardly changes at all. That one car greatly affected my mean and standard deviation, but it hardly affected at all the median and the IQR. So if our data is symmetric, use mean and standard deviation. Just do it. If it is not symmetric, if it is skewed either left or right, use the median and the interquartile range. All right. Questions on this? Okie dokie. So this looks really like a lot of words, but I'm going to break it down and we're going to math it out and it won't be too bad. So in order to check for outliers using quartiles, first thing you want to do is find your Q1 and Q3. Not too hard. Then you find your interquartile range. So you just subtract Q1 from Q3. That gives you your interquartile range. I'm just going to write that up here. Q3 minus Q1. Then we need to find what we call the fences. So the fences are the cutoffs for determining outliers. Once we find the fences, anything that's outside the fence is an outlier. So any cows that escape the fences become outliers. So our lower fence, you take Q1 and you subtract 1.5 times the IQR. I don't know where the 1.5 came from. They didn't ask me, but it is what it is. So you take 1.5, multiply it by the IQR, and subtract it from Q1. That gives us our lower fence. Any data value lower than that lower fence is an outlier. So then you take Q3 and you add it to 1.5 times the IQR. And That gives us the upper fence. Anything higher than the upper fence is an outlier. So we have those fences that contain all of our usual data values. Anything outside of those fences is considered an outlier. We're going to do some math with it. We're going to do that and it'll hopefully help you in your noggin. So let's go and take a look. All right. So take a look. My first and third quartile for the speed data is 28 and 38. Those were my first and third. So my interquartile range, this is IQR right here. All right. So I take Q1 and I subtract 1.5 times the IQR and I get 13 miles per hour. This is my lower fence. Then I take Q3 and I add 1.5 times the IQR and I get 53. This is my upper fence. Since in our data there are no values that are greater than 53, because we're not including that 100-mile-per-hour car, we threw that one away. We have no data values higher than 53 or lower than 13, so there's no outliers. We're going to do this with the collision data in just a minute. Questions before we do the collision data? All right. I have it written down on a separate sheet of paper. Okay. So for the collision loss data, our Q1 was 735 and our Q3 equals 4668. So first thing you need to find is the IQR. So I take Q3 minus Q1. So our IQR is 3933. So this is our super important value right there. So in order to find my fences, I'm going to take 1.5 and multiply it by the IQR and subtract it from Q1. So it's going to be Q1 minus 1.5 IQR. So it's going to be 735 minus 1.5 times 3933. You're going to get a negative number, but that's okay. So my lower fence is at 5164.5. That's the lower fence. Let's do the upper fence. I'm going to write this down here, lower fence. Okay, Q3 plus 1.5 IQR. This is going to give me my upper fence. So I take Q3, which is 4668. I don't know, my brain just decided to shut down for a second. 1.5 times plus 3933. This is going to give us our upper fence. $10,567.5. This is my upper fence. I'm going to write this right here. I'm going to flip back to the other data real quick. Our upper fence is at 10,567.5. I'm going to flip back. Boom, 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 boom. Where are we? There we go. Okay. Our upper fence was 10,565.5. This right here This number right here, the 21,147, that is higher than that upper fence. Therefore, that is an outlier. So that's the data value that's higher than that upper fence. So I'm going to go back here. So one outlier. Let's go different color. Outlier. Oh, okay. At 21,000, 147, 147. So that super expensive car that got damaged, that one is an outlier. This one is considered unusual. Uh-oh. Yeah, I thought my little box was fine. There we go. All right, what questions do you have about finding outliers with quartiles? I was ready for the fun part. I think we get to do box and whisker plots next. They're so fun. Well, I think they're so fun. But I also thought majoring in math was fun, so take it with a grain of salt. Okay. Oh, five number summary first. Okay. The five number summary is simply all of the important numbers from your data set. They're just the important numbers. I kind of mentioned it before when I talked about this is all you need. The five number summary, I'm going to pop over to my calculator real quick because this is helpful. The five number summary is simply these bottom five right here. The minimum, Q1, median, Q3, and max. That is literally your five number summary. When we sometimes we have really big data sets and it's cumbersome to have all of the numbers there all the time. Sometimes it's helpful to be able to just pull out the important numbers and use those because we can get just about anything we need just from the five number summary. Now, when you write down a five number summary, you don't have to label them. As long as you put them in order, then we know what the numbers mean. This is the order they go in. It's exactly the same order the calculator gave you. Minimum, Q1, median, Q3, and maximum. If you write them in that order, people in the know will know exactly what they mean. They're going to know what those numbers mean. So a five number summary, I know there's one question in your homework talks about a five number summary, and I'm going to go over it at the end, but there's one question there. So if you just write down those numbers, people in the know will know what they are. On the next screen, we're going to do five number summary. Okay. So the speed data, our smallest speed data value was 20. And we found the quartile one. Our quartile one was 28. The median was 32.5. Quartile 3 was 38. And our maximum was 40. That is literally all you have to do to write down a five number summary. You just write down those five numbers. By using this, I can tell where the middle of my data is. I'd be able to calculate where outliers are and be able to determine if there is an outlier just by this data because I can find my fences. I see the minimum, I see the maximum. You can see everything you need just from these numbers. So let's go ahead. I'm going to get a different color because I can. And we're going to put the five number summary down for our collision data. Now, once we put these numbers down, I want you to hold on to them, put them somewhere where you can find them easily again, because we're going to use them again for a box and whisker plot coming up. Okay, so for this, I need the lowest value. My minimum, I wrote it down. My minimum, I didn't write it down. Oh, it's 180. Minimum was 180. Q1 is 735. Our median is 1805. Q3, 4668. And then the maximum is that 21,147. Just by looking at this data, we'd be able to calculate our whether or not we have an outlier, and we would be able to see that 21,147 is above that. We don't need any of the other information. We don't need all of those other data values. I mean, of course, don't throw them away. Don't throw them in the trash because you may need to look back for whatever reason. But this five number summary gives you almost everything you need. So questions on the five number summary? Uh-oh. I just got kicked out of Zoom. Okay. Are y'all still there? My other computer kicked me out. And okay, yep, I see you.
Yeah, you're all
Thank
good.
you. Thank you. I was like, oh no, because all I see is the screen I've shared on my Mac. So I'm like, oh no, what happened? Okay, good. It just must have been my PC was being wonky. All right. So we're going to move on to a box plot now. I'm going to tell you a box plot might be a little bit confusing when all you see is the words, but we're going to draw one together. We're on slide 18 of 24, so we're almost done. And then we have other business. Okay. One Yeah, so going back, exactly. So if I was to find my fences, so I can find, so those on the recording, what it says, what the chat question says is, so just by seeing that one number doesn't belong is how you notice an outlier. Yeah, so here, I mean, I could see that number's really big, but I can use my Q1 and my Q3. See a second here. So I can use these right here to determine the interquartile range, which would help me to find my fences because I don't need any of their other data to find my fences. So once I do this, so I notice back here, all I used was Q1 and Q3 to find the fences. And then I see that this number, this outlier here, this number right here is above my highest fence. So just by looking at this, I wouldn't be able to tell, but I have all the pieces that I need to do the math, if that makes sense. That answer your question, Kiana? Okay, good. All right. So here's what's going to happen. Here's how I'm going to tell you how to do it. I'm going to show you one that's already done, and then we're going to draw a box plot together. Okay. The first thing you want to do now, I usually don't find the upper and lower fences first because usually I find my five number summary first. I will go with the five number summary first. It doesn't say it here, but that's what you're going to want to do first. You're going to want to find your five number summary. Then um, you're going to want to find your fences. After that, find the fences. You're going to want to draw a number line. So we're just going to draw a standard number line. The standard number line is just along the bottom, and you figure out some intervals that, like tick marks, where they go, that works for your number line. I'm going to show you on mine. I've drawn the one that I'm going to draw for you. I've done it a ton of times, but when I first started doing it, I had to experiment on what worked best with my data. So you might have to do that. You make sure you do it in pencil so you can erase it. You'll want to label your upper and lower fences. You're also going to want to label your where your quartiles are and where your median is. And I'm going to show you how to do that. They're going to be vertical lines at the quartile 1, median, and quartile 3. And we're going to enclose those in a box. That's the box part. Next page. From quartile 1, from the edge of your box, you're going to draw a line, which is a whisker, a horizontal line that goes from the box to the last data value inside the lower fence. So go all the way to the last data value inside the fence. Then you draw a line from Q3 and draw it up to the last data value inside the upper fence. These lines are called whiskers. Anything that is an outlier, you're going to mark with an asterisk. I know this is a lot and it's weird with just words, but bear with me because we're going to do one by hand. And it'll seem a little bit tedious, but I think it's going to help. Right. So I'm going to show you one already done, and then we'll draw one. So every 6 months, the Federal Reserve Board conducts a survey of credit card plans in the US, and we take a look at the rates that credit card issuers have. We took 10 of them, and we are going to construct a box plot with the data. So here they are. There's the interest rates of 10 of our 10 different credit cards. All right. So notice how we calculated our upper and lower fences. So my lower fence is at 8.4. My upper fence is at 18. Look underneath of the box plot. It is a standard number line. Even though these numbers are not all just whole numbers, they're not all just whole numbers, but it's okay. The number line underneath is just a standard number line. The box plots, you're not going to see individual data values super well. Box plots are kind of more to get an idea of a shape, and sometimes we'll use two box plots and we'll compare them to each other. So you're not going to see exact data values on here for the most part. My lower fence is at 8.4, but notice out here, this is an asterisk because I have an interest rate that is at about 6.5 or 6.4%. I have an interest rate that is below that 8.4. That is my lower fence. Notice also that the whiskers do not go all the way to the fences because the last data value inside my lower fence is at about, it looks like it's at about 9 point, what is it, 9.8-ish. So I just draw that whisker to go down to that last data value inside the fence. This right here is Q1. This right here is Q3. This is the median. We do not label these things. I'm just labeling them so you can see them. That is the median. This whole thing inside the box, oh, why did I do that? This whole thing inside the box here, this is my IQR, right? Because it's in between Q1 and Q3. Oops, I should say IQR. I was just, So this is the IQR because it's in between Q1 and Q3. It's just lovely little IQR in there. And my whisker up here on the other side of Q3 goes to the last data value inside the upper fence. So it looks like it is at 14.5, 14.6-ish. It's not exact. All right, before we draw our own, any questions? Okay, let's draw one. All right. Hopefully you have room on your paper. I'm going to show you a couple little tricks. You are going to have to draw a box plot on your test. You will have to draw one. I'm going to give you a data set on your test, and you're going to draw a box and whisker plot. Just letting you know that that's a thing. I want full transparency here. I'm not in the business of tricking people. You will be drawing a box and whisker plot on a test. Okay. And you're going to draw it on paper and then you're going to upload it. So don't worry about like how am I going to draw that on the computer? No, you're going to draw it on paper. All right. First thing we need is we need a standard number line. So I'm going to draw this down here. This is really ugly, but as soon as I hold it, it'll be fine. Okay. I have learned by doing this in the past that the um, best scale for my data is to each tick mark to be 500, but I only label every 1,000. That is what I've learned is a good idea here. So I'm going to start at 0, and this would be 500. So this is 1,000, uh, 2,000, And I'm going to show you a little trick here in a minute. So don't go too much ahead of me while you're labeling. Trust me, it's going to fit. Well, I don't know. I'm kind of spreading them out a little more than I like. Okay, no, it'll be okay. Okay, I'm stopping at 11,000. I'm going to extend my line just slightly. Oh, no. Let me go back. Put that back. Go back. Okay. I just want to get rid of my arrows. Stop it. Okay, let's do it this way. Okay. Okay. I'm going to extend it just slightly because I need just a little bit more. Okay. All right. So when you have, notice I have the value, I have the data value of, second here. I have a data value of 10,036. The next value that I have is at 21,147. There's a huge difference between those. I'd have this big empty space on my number line. So here's what you can do. So you can put what's called a break in the graph. By putting that little squiggle there, I am breaking the graph. I'm essentially cutting a piece out of the graph, and I'm alerting everybody with the squiggle that I cut a piece out of the graph. So now I can start counting again by whatever I want. So my outlier is at 21,147. So I'm going to put 21,000 right here. And then I'm just going to put one more tick mark after that, which would be 21,500. So I cut a big chunk out of my graph, and I'm missing a zero. I'm 11,000. Cut a big chunk out of my graph, but I can still see everything. I still see everything that's important. Okay, so now that I have the number line, now in your notes, you might want to like put a little arrow to it and say that this is a standard number line. One of the most common errors on the test is people not using a standard number line. They'll put the data values on the line. I don't want those. I want a standard number line. So maybe put an arrow or something to remind yourself it needs to be a standard number line. All right, I'm going to switch colors just because it's fun and because sometimes I get bored with the same color over and over again. I don't know if you can relate, but there you go. All right. So now I'm going to put vertical lines at the median, Q1 and Q3. So my median is 1805. So it's, I don't know, right about there. You're just guessing at this point. Okay. That's my median. Q1 is at 735. So it's going to be over here somewhere. There's my vertical line. I want a little bit taller. Okay. Good enough. Okay. Then I need another one at Q3. Q3 is at 4668. Wow, it's way up here. Okay, there we go. And then we just enclose all of this in a box. It's not perfect, but that's okay. It doesn't have to be perfect. I'm not looking for perfection. Okay, so there's my box for my box and whiskers. Now I'm gonna put the fences. My upper fence was at 10,567. So we put it as a little, like a hard bracket, square bracket, whatever you want to call it. Now, the other one was really weird because it was at negative 5,164. Now, I don't know about you, but I do not want to make my graph go all the way down to negative 5,164. Usually what I will do is I just kind of put it off the graph. Sometimes I will label it and say negative 5,164.5. Wait, no, it's just, no, it's no, oh, it is 0.5. But I mean, you need to show that there is one, but it's kind of a ridiculous one. So it just kind of is hanging out there. I'm not going to give you a ridiculous one for your test. Don't worry. Okay. Now we're ready for the whiskers. The whiskers go to the last data value that's inside the fence. So on the lower side, the last data value inside my fence is at 180. So I'm just going to draw my whisker to about where 180 is. It's probably about there. And then the upper whisker, the last one inside the fence, is at 10,036. So it's going to go way down here, just about to 10,000. Do not draw the whisker all the way to your fence. It goes to the last data value inside the fence. That's another thing you might want to write down. Last, uh-oh, last data value inside the fence. Okay, one last little piece and we are done. All we need is the outlier. The outlier is an asterisk. My outlier is at 21,147. So it's, I don't know, right about here. That's it. There's our box and whisker plot. And it is lovely if you ask me. Okay, now's the time for questions. All right. So,
Can,
yeah,
sorry,
go
can
ahead,
you just
Aubrey.
review what data are we pulling these numbers from?
This is from the collision data.
Okay, thank you, thank you, thank you.
Yes.
Okay.
Sorry about that if I didn't make it clear.
I'm pretty sure I got kicked out of the Zoom for a couple of minutes, so I just came in like I was confused.
Okay, no problem. Sorry. It happens sometimes. That's the beauty of technology. At least it's recorded. So if you need to go back and watch this again, you can. There's also a video that is only this in the materials. This is it's not a bad one. That one's not the Zoom ones are almost always better. The one that is in the week's material is pretty much on par with this. If you just go to the second part of the 3.4, 3.5, it has just this. I decided to put it in its own video because it's so far into the lesson. So if you need it, you can go there as well. All right, any other questions before we move on? We have one more slide. All right. So by looking at this right here, I think that we can tell that this is left skewed. I think you can tell that by looking at this because this is my big long tail. Hold on. Don't you? This is the big long tail, and this right here is where the bulk of my data is way down there. So this is a left skew. I'm going to go to this last page right here, and you can see what the different plots look like when they're skewed left or right, or when they're symmetric. You can kind of see by where the tail is. Now, most statisticians say this isn't the best way to determine skew. No, it's not, but it's going to give you a pretty good idea. And I absolutely will accept it. Now, what was I going to say? Excel, when it does box plots, it plots them vertically, and I don't really care for it. So it would be like your box right here, and then it would have your whiskers up and down like that. I'm not the biggest fan of it, but it does work, and some people will put it in their final projects, which probably either week 4 or week 5, I'll give you your final project. I know I keep talking about it. It won't be very long, and I'll give that to you. But this is just kind of I'm not going to ask you to do this. I just kind of wanted to show it to you because it's interesting. All right. That was our last slide. I'm going to show you one of our homework questions. Before I do that, I'm going to show you a homework question and then we're going to go to the lab. So before I do that, is there any questions about what we've just covered? Yes, right. For some reason, I have my left and my right mixed up. You're absolutely right. Kiana asked if it would be right skewed instead of left. Yeah, it was my brain. I mixed up left and right. I swear I know the difference between my left and right. Thank you for that. I appreciate you. It's right skewed. Yes. All right. Okay. I'm going to go to a homework question. There's one homework question that I get the most questions on every term, and it is in 3.4 and 5. Let me see here. Let's see if I get my internet will get me there. And it is scrolling, scrolling, scrolling. It's this one right here. It says the 5-number summary of a data set was found to be this, and it asks you some questions. So these numbers right here are not an entire data set. These numbers right here are just the 5-number summary. So the number 1 is your minimum. Number 2 is the maximum. 10 is the median. 17 is Q3 and 20 is the maximum. So just when you get to this question, realize that this right here is the 5-number summary and not a data set. So that's like the biggest error that I see. People will try to um, find the median of the lower two here, and they'll get like 1.5, and they'll get like 18.5. This isn't the data set. This is the 5-number summary. So to get your IQR, you would just do 17 minus 2, and you would do your normal math and determine where your fences are. So I just wanted to point that out. Okay. Um, Now I'm going to go to the lab, and I'm going to have to, hopefully it's not too confusing. I'm going to have to jump to my, show you how to get the tool you need on my Mac. Then I'm going to jump over to my PC and show you how to get the tool there. There's also a couple of videos in the week 3 materials that will walk you through it as well. I just kind of want to show you how to do this. So I'm on my Mac right now, and not everybody's Macs are the same. I've learned that as well. But so on my Mac, this is what my Excel looks like when I first open it up right here. And I'm going to need a specific tool to do this lab. So I'm going to click on data up here, and over here, got it. Okay. Over here, it says analysis tools, but the rest of it is blank over on the top right. I can't zoom in on it. It won't let me. Top right, it says analysis tools, but then it's blank underneath. I need to add a tool to this. So I'm going to click on analysis tools, and I'm going to check the box that says analysis tool pack. And then when I click OK, notice now it says data analysis. That's what needs to be there. I need that data analysis. Okay, I'm going to stop sharing my screen, and then I'm going to stop sharing. Then I'm going to share on my PC. Uh-oh. So when I share, maybe I'm going to share on my PC. Okay, that's going to take a second. There we go. Okay, now on the PC, you click up here on data. Okay, you notice that this over here on the top right is empty. There should be a tool there. I'm looking for a specific tool there, but I don't have it. So I'm going to click on File and scroll all the way to the down to the bottom and go to Options. So File and then Options. And I want to go to add-ins because we're going to be adding something in. So click on add-ins, and down at the very bottom it says manage, and it says Excel add-ins, and click go. It pops up this right here. I'm going to check the first two. When I check the first two, data analysis pops up here. I'm going to walk you through that one more time. File, all the way down to options. We're going to go to add-ins right here. Then the very bottom over here, it says manage Excel add-ins, and click go. We want analysis toolpack and analysis toolpack VBA. That's what we're looking for. And I'm going to click OK. And then I'm going to stop sharing my screen. If it'll let me stop sharing. And I'm going to share over here. Share my screen. Share screen. There we go. All right. Now that we've enabled that, all of the rest of it looks the same. Everything else is going to look the same. Okay. So I'm just using my continuous data from the lab one. And so I just expect you to do the same thing. Okay. So I want to use the data analysis tool. So I'm going to click on the data analysis tool and scroll down or scroll up. We want descriptive statistics. So data analysis tool, we want descriptive statistics, and you're going to click OK, and this screen's going to pop out. The input range is your data. So click on the box for input range, and then just click on the top one and drag all the way down to the bottom of your data. I have a ton of it because I'm a little extra. Okay. The output range, we have a specific place that we want to put it. If you don't do that, it's going to open up a whole new worksheet page, workbook page, and it's going to throw it over there. So I want it to go in this box. So I'm just going to highlight my box. If you highlight the old box, whole box, it's not going to matter. I'm just doing 3 columns because I don't need any more than that. The next thing you're going to do, once you do that, click on Summary Statistics. So input range is all your data. Output range is where you want it to land. And then Summary Statistics. When I click OK, it gives me this. I usually make it bigger so I can see. So I'm going to highlight it all, and let's just make our font a little bit bigger so we can see what's going on. Okay, there we go. This is really cool because it gives us a ton of information here. It gives me the mean, the standard error is something we're not using right here. It gives me the median and the mode is standard deviation. It gives the range, maximum and minimum. It tells you all of them added up, and it tells how many you have. There's a lot of stuff in here we don't use, but there's a ton of information here that we would normally have to calculate ourselves. Now, all of these yellow boxes on the left, I want you to use Excel tools to populate them. The purpose is for you to learn Excel. That's why we're doing this, so you can learn how to use Excel. So we're going to use Excel tools to populate this. So Excel, basically, when you put an equal sign in Excel, you're telling it, I'm going to tell you to do something. So for example, if I put an equal here, then I'm going to click on this value right here, and it's telling it, insert that mean in there. So I want this to equal P6, and I'm going to hit enter, and it's just going to populate it. I do it again with standard deviation. Put it in here, hit equal, click on the numbers for standard deviation, and hit enter. I'm going to ignore number 2 for now. Go down to number 3. I put in equal, find median, and hit enter. Do the same thing with mode, equal. But that's not an equal. Equal, mode, hit enter. Beautiful. I'm skipping number 4. We're coming back to it. All right. The minimum, once again, equal, minimum, hit enter. Now let me show you how to do quartiles. It's beautiful how it will do it for you. Once again, you're going to hit equal. Type in the word, start typing in quartile. Remember we talked about, do we include or do we exclude? We're going to include. Doesn't really matter all that much, but we're going to include. Okay. Says array. Array means what data are you using? So I'm going to highlight all of my data. Just like we did. I'm going to highlight my data. Okay. I highlighted my data. Put comma. And I want quartile 1. So look, it gives you the options right here. I want quartile 1, and I'm going to close my parentheses and hit enter. It gave me Q1. Q2 is just median. So equals median, enter. It's just median. Quartile 3, we do exactly what we did with Q1. Fact, yeah, exactly what we did. equals, start typing quartile. It's right there. I want included. Array is all of my data. Highlight it all again. Boom, boom, boom. Okay. Come back up here, comma, quartile 3. Close my parentheses and hit enter. High is just your maximum value equals, go up here to maximum, hit enter. Okay. So for IQR, we're going to actually do math. When you do math in a cell, you type equal first and you're telling Excel, you're going to do some math for me. So I'm going to hit equal. I want my IQR to be Q3 minus Q1. So watch this. I'm going to click on the Q3, hit minus, then click on Q1 and hit enter. It calculated that IQR for me. All right. Now that we've done that, I'm going to jump back up to number 2. So it wants to know if we have any outliers. There's a couple of different things that you can do. Probably to me, the best way to do that is to find the upper and lower fences. Nope, we want z-scores. I just lied to you. Okay, I'm going to use the 2 standard deviation rule to find the upper and lower limits. So the 2 standard deviation rule tells me how anything more than 2 standard deviations away from the mean is an outlier. I like this better than using z-scores, but if you want to use z-scores, that's fine. I'll talk about that in a second. So I'm going to use Excel tools to do that magic. I am not requiring you in box 2 to use your Excel tools. Only the yellow ones are you required to use the Excel tools. I'm going to use the Excel tools in here. I'm going to put lower right here. I'm going to type in lower. Then I'm going to type in upper right here, just because I want to show that this is the lower end and then the other one's the upper end. So I'm going to show you how to calculate 2 standard deviations away from the mean. So once again, equals is telling Excel that we're going to do some math. So I went equals the mean minus 2. We use an asterisk for multiplication and then click equals on the standard deviation. So I did mean minus 2 asterisk standard deviation. I hit enter. It calculated my lower value. I do it again. Equals my mean plus 2 times the standard deviation. I hit enter. That's my upper. So now I can type in here that I have 1, 2, 3, 4, 5, 6, 7. I have several. I think that I didn't. I think what happened is I think I didn't highlight all of them. But anyway, so you would say that I have these values are outliers because they are below the lower value. The other way to determine it is to find the z-scores of your data values. So if you say no, if you do answer no, that you don't have any outliers, you can either say that all of my values are in between these two, or you can calculate the z-score of your lower and your highest value. So I'm just going to calculate a z-score here. I'm going to show you what that looks like. I'm just going to pick any data value so I can show you how Excel does that. So I'm going to hit equals. We're going to put parentheses. So remember, a z-score is the data value minus the mean divided by the standard deviation. So I put parentheses. I'm going to pick this lower one right here, lower data value, hit minus. There's the mean. Close the parentheses. Division is just your slash right there, divided by, click on the standard deviation. Look, all the math is in there and hit enter. Gave me a z-score of negative 3.623. But if you say you don't have any outliers, you can say The z-score of my lowest value is negative 1.8, and the z-score of my highest value is 1.85. Therefore, I have no outliers. So somehow you need to justify why you say you don't have outliers or why you say you do. Even though it says show those z-scores, I'm going to be a little flexible as long as you can justify and give me what those numbers are for the upper and lower, or give me z-scores. As long as you justify, I'm good with that. Does that make sense? We okay? Okay. Lastly, number 4. So, um, what I want from you on number 4, it says, given your mean and median, what is the skew of your data? All I want for you here, I like mine, for example, I would say that the mean and the median are almost identical. Therefore, my data is bell-shaped. If yours is skewed, say my mean is less than my median, therefore, or my median is less than my mean, therefore. I want you to look at the definitions. Remember that thing I told you to star last week? Look at that and say, compare your mean and your median and tell me if it's skewed and how you know. So that is it on the lab. Any questions on the lab?
I'm pretty sure you said we're going to use our continuous data from the first lab, so just like those 20 data points are okay, right?
Yes, 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 yes.
All
Just
right,
use,
cool, got it.
don't collect anything else unless you really want to, but you don't need to do that. Just use that continuous data.
You got it.
Okay. Anyone else? Okay, I'm going to make one comment about the test. I'm going to tomorrow, I will put up a practice test. The practice test will have no content on it. I think the hardest math on it is there's a question that says 2 plus 2 equals, but it is not content related. All it is for you to download the browser, the lockdown browser, and to use it, because nothing worse than getting to the day of the test and the software doesn't work on your computer, or you can't figure it out, or there's some issue with your webcam or whatever. So all the practice test is going to do is allow you to test that it's all working well for you. That's all it's doing. So you're going to get a couple of extra credit points. Now, this couple of extra credit points are not enough to do any kind of miracles. I don't believe in extra credit points that like greatly affect your grade, but it'll be a couple, and everybody likes a couple of free points, right? So that's going to come out tomorrow. Yes, you can use notes on your test, any notes you generated. So if you downloaded, you printed out those PowerPoints and you wrote on those and put notes on those are notes you generated. You can use them. If you printed off a normal curve, the empirical rule paper, and put it into a sheet, I don't care if you do that. Go ahead and use that. You generated that. So any notes you generated, you can use your calculator and notes. You can't use your book or your friend, but you can use those. You're going to need to use your fancy schmancy. It will be necessary. Um, any questions on, oh, it's 90 minutes. The test is 90 minutes, unless there's some accommodation giving you more time. 90-minute test. Any questions on that before, because we're still on recording, any questions for on recording at all about anything? How many questions on the test? I don't know. I never know how many questions are on the test. So I'm sorry about that. Yeah, I just don't know. All right, I'm going to turn off the recording. Where is it?